Hello and welcome. This is Dr. Sonu Kumar Gupta, a assistant professor working in an institute. So here I am going to deal with engineering mechanics. So as per the institute syllabus, whatever syllabus we are going to cover, in this respect we are going to uh, give your syllabus and so one by one we will discuss. Here it is going to categorize in module. So just we are talking about unit number 1. So here module 1, that is about introduction to engineering mechanics and its basic concepts. In that basic concepts we are going to study about type of forces, resultant force of a system, parallelogram law, Lam's theorem, then forces and its components, moment due to forces and principle of moments. Then in module 2 we are going to cover about coplanar force system, couples resultant of any force system, Verignon theorems, equilibrium of force systems, introduction to free body diagrams and equation of equilibrium. So these are the contents that we will cover in coming session, but simply we will go for a little bit introductions about engineering mechanics. So here that physical science, branch of physical science, that is mechanics is the branch of physical science concerned with the state of rest or motion of bodies that are subjected to action of forces. If any body that will be subjected to action of forces, different type of forces if applied on the body, so how body is going to react, what is going to happen to the body, to the members, to the structures, that we are going to deal with. Here first we will categorize the mechanics. So here rigid body mechanics, deformable body mechanics and fluid mechanics, but we are going to concern about only rigid body mechanics. So first part we are going to discuss why it is needed, because many types of structural members, mechanical components and electrical devices that we are going to analyze, going to design. So that's why it's essential to study about rigid body mechanics. So this is the very important if a students going to study about civil engineering, mechanical engineering, aeronautical engineering. So this need to study is important, but basic knowledge should be there for the all students, so students can understand what mechanisms happens to any structures, any structural members. So here rigid body mechanics, rigid body is an idealized object where the distance between any two of its particles remain constant. So we are talking about internal particles in any of the object. Internal, if we consider two particle, so after the application of any forces, that particle position not going to change. So that is the meaning. It means a rigid body does not deform, bend or change its shape. But if you say this is not true in practical sense, while because any of the material, any of the object, if you are going to apply the forces, so that objects going to have deformations, bend, and it may change its shape, but it's very minute, very small changes that we may assume is not going to happen, but in practical sense it's going to happen. Again, division of rigid body mechanics. So here two types of concept we generally discuss: statistics and dynamics. Statics deals with the equilibrium of bodies which are either at rest or in move with a constant velocity. Then dynamics, it is concerned with the accelerated motion of bodies. So this is the historical development about static and dynamics. So as you study, as you can read, so you'll get, because here little bit it is furnished the details about Archimedes, then Galileo Galilei's, Isaac Newton's, Euler, D'Alembert, Lagrange, and many more scientists were invented very important findings. So that is still we are using, and that is very much applicable for our study. So here that basic quantities as students used to study at their lower classes. So we hope they know this basic concepts. Then idealization, how we are going to idealize a particle, a rigid body, a concentrated force. So many more things will come that will go for idealizations, but here that you need to know about the concept, what is meaning of idealization. As particle is there, so if one object is there, so generally we say this is a particle, small particles from a one dot we can represent, that is a particle. Okay, so here particle has mass but size can be neglected. Why neglected? As you are going to compare it a bigger object, very small object is nothing, so that we say size is very small, so we may take the mass of that particle but we neglect the size. Then type of forces, here the different type of forces we have taken, internal and external forces. Internal forces, forces acts within the body, that simple examples we can take stress and strain. So this is very good examples. While force is applied on any object, so whatever reactive forces within that object, internal forces appears, that deals with stress, load per unit area, and whatever changes going to happen in that object, in that object, so that going to define about strain, so that happens within the object. So whatever forces is applied within the object by the different particles, so that forces is called internal force. Then external forces, forces acting on the body from outside sources. If from outside you are applying the force on the body, that is called external force. Then applied forces means pull or push. We are going to apply the forces from outside, either we are pulling one object or pushing one object, means tension or compression. Tension going to happen while we are pulling the object, and compression going to happen while we are going for push force, or going to compress from both the sides. Then gravitational forces and reactive forces. Here we can say reactive forces, applied forces. This is the example of applied forces. Reactive forces, if we kept one object on the ground, whatever forces is being applied by the object, that again that reactive forces is going to apply from the ground. So we can indicate this. This is a reactive forces. Then same way concentrated or point force, as a force is idealized that it's going to act at a point. So here at a point is going to apply, so that we can say this is a concentrated force or point force. Then distributed force, so it's going to categorize in two way, uniformly distributed and uniformly varying. If see, this is the force as we indicate here, if it is very much uniform, means at every point whatever forces are acting, that is equal, such type of force we call it as uniformly distributed. And if force going to vary. Suppose here small forces going to vary, here bigger forces. If you see how it's going to vary, such type of force is called uniformly varying force. Means in equal manners it's going to increase. Means there is no sudden increase, there is no sudden decrease, but it's increasing slowly, but increase is there. Means variation is there. Then pressure, that you can take example of dam. While we are storing the water in the reservoir, so dam going to bear the pressure from a side where water is storing. So here at the bottom maximum maximum pressure will be acted, and from the top, like if you say you can draw like this. So this is maximum pressure, and at the top minimum pressure, so that you can define. Then reaction forces, how reaction going to happen? So this happens because of various support reactions. That first, roller support, means if you are putting a roller support, that object is going to move in one direction on where we kept the object. It's going to move in one direction. Suppose it's moving in horizontal direction, but this support will not allow to move in vertical directions. So vertical direction movement will not be allowed. So here reactions, so as this is free to move in x direction or horizontal direction, so there will not be any reactive forces. Because if you take example, if a student in the class free to move anywhere, so he will not react. Again, if teacher will stop them to move anywhere, so he will react. He may not show, but he will react internally, or he may show his reaction. So as it is allowed to move in horizontal directions, so that we can say, but in vertical directions there is no movement. If you will take hinge support, so it's going to prevent movement in horizontal and vertical directions. So if it is going to prevent, wherever prevention will come, there a reaction will come. But it's going to rotate, because this is hinge support, it's going to rotate. If it will rotate, it means it is going to allow the rotation. So it's not going to allow the translation, but it's going to allow the rotation. Then fixed support, if you will take the fixed support, what will happen? Totally fixed, means no movement in vertical direction, no movement in horizontal direction, but and also it's not going to rotate, also prevent rotation, means that rotation is not allowed, because this is a rigidly fixed. Fixed means totally fixed, rotation not going to allowed. So three reactions will come. Suppose one reactions will be second reactions, one rotations, means one moment will come. So this is about session. It's very basic. So I hope next sessions I will come with some another topic. Okay, thank you.